question from electromagnetic theory. This is from the S parameters. And in this, a two-port network was there whose S parameters are given already. And if this two-port parameters has been extended, okay, transmission line sections of electrical lengths are added to the input and output port of the measurement process. The S parameters of the resultant two-port network is what? That we need to find out. So let us try to understand. See, first of all, the S11 parameter, if you see here, it is nothing but V1 minus on V1 plus. Okay, reflected voltage upon the forward, reverse voltage upon the forward voltage. Right. Now let us take S11. So let's say here it is V1 dash, right? That's voltage coming here. So V1 dash will have two voltages, V1 dash negative, V1 dash positive. So I can write here S11 dash is V1 minus dash, V1 plus dash. Okay, now what is V1 minus dash? These voltages are nothing but the extra voltage which they have traveled further. Right? So if you look at V1 dash from Z1 is 0 here and this element, I can write V1 minus dash is V1 voltage here at this point, V1 minus e to the power j beta 1 L or j beta L1. Right, that much extra phase which will come because of this length. And V1 plus dash is V1 plus e to the power j beta. Right. Now, if you put this in this equation we will get S1 dash is V1 minus e to the power j beta V1 and V1 plus e to the power minus j beta L1. That will become S11 e to the power minus j beta L1 into 2. Beta L1 is theta 1, so that will become S11 e to the power minus j to theta 1. So that will be your S11. I hope this is clear to you, because V1 you can take it reversely. Here both the waves will be there, right? So one wave is for traveling like this direction, which is V1 plus. Other wave is traveling like this, which is V1 minus V1 plus. Now, this wave has traveled extra distance from here to here. This wave has traveled extra distance from here to here. So that extra distance is given by this. Okay, that is was because of delay, you will use only the phase. So now either if you see, look at the option A and B, one of the choice meets here. Let us find out S12. Okay. S12 in general it is V1 plus upon V2 plus, right? So that is a thing which S12 will be. Now S12 dash will be given by V1 plus dash on V2 plus dash. Now V1 plus dash is V1 one. Let me just write it. It is V1 minus and V2 plus. Right? So it is V1 minus dash V2 plus dash. Now V1 minus dash, we have already seen this. From this equation, it is 1 minus e to the power minus j beta, right? Similarly, V2 plus dash is going to be V2 plus. Now V2 plus is what this side, right? Is e to the power j beta L2. If we substitute in this, we will get S12 dash is this upon V1 minus e to the power minus j beta L1 and V2 plus to the power a beta L2. Taking the ratio of this, you will get S12 e to the power minus j beta 1 plus beta 2. Now, if you see the relationship among the four, we need not to find out that this and this, if we got, we can write what is the correct answer. Correct answer for the two options. So, everywhere the magnitude will remain same, only the insertion of phase will happen. So, that will occur a phase change in the parameter. Of course, we can also attempt this problem with respect to S21 also, right? We can assume V2 equal to 0 here and we can find both S11 and S21 this side. But the result is same. Both the cases you will get. Of course, we have found only two parameters. We can find the remaining parameters also, but not required at this moment because you can always see that there is a kind of symmetry occurs in the parameters. Get the other. That's the end of question from electromagnetic theories. Question from electromagnetic theory. This question is slightly complicated in the sense multiple options can be right. Second thing is we need to understand clearly how to identify the left hand and right hand electrically polarized wave. The electric field of a plane electromagnetic wave is given by the equation. To determine what combinations will give light to left hand electrically polarized wave. Okay. So let's see one by one. Each of the cases we have to check all the four options. Okay, it is not about determining the right option, but we have to check all the four options. So for determining a polarization, you can put z equal to 0. So electric field expression can be written as Ax C1x cos omega t plus Ay C1 by cos omega t plus theta. Okay. So one by one we will put the values and we will check the kind of polarization. So option A. So C1x is 1 and C1y is 1. Theta is 5/4. So electric field in this case will become Ax cos omega t plus Ay cos omega t plus 5/4. Okay, now we'll see. We'll take two time instants and we'll see that those time instants, how the wave this vector is moving. Let me just draw this. So let's say t equal to 0. T equal to 0. This will become Ax, A vector. right? This will become Ax. E will become Ax plus omega t here 0 cos pi plus omega t. So it is 1 by root 2 here. So somewhere around 0.707 A1. Resultant is somewhere. Now at t equal to you can write pi by 2 omega. E will become, if you put t equal to pi by 2 omega here, so or omega t is equal to pi by 2. So you will get, or you can take pi by 4 omega also. That is also the case. So this will become ax cos pi by 4. Cos pi by 4 is ax. So ax by 2. And this will become cos pi by 4 plus pi by 4 cos pi by 2. Cos pi by 2 is 0. So that is 0 dot a1. So the resultant has moved from here to here. Okay. Direction is like this, right? As the time is increasing, this vector is moving from this position to this position. So once it is moving from this position to this position, which hand movement of finger curl is matching this? It is the left hand which is matching this, right? So right hand is not matching. So A is the right answer. A, option A is one of the right answers. We have to see other options also, but A is yes. Now coming to option B. I will directly write E is AX 2 cos omega t plus AY cos omega t plus pi by 2, right? So at t equal to 0, electric field equation will become 2ax cos pi by 2 0, 0 ay. At t equal to pi by 4 omega, this will become, I can write this even pi by 2 omega also here, not an issue, just for the sake of simplicity. This will become a cos pi by 2, so that is 0, 0 into ax. And here pi by 2 plus pi by 2 will become pi, cos pi by is minus 1 ay. Let us plot this in a two-dimensional plane and see how this. So first equation, if I plot it, is 2 times ax. And this one is, this is resultant here because y component is 0. The second case, it is minus ay. It is only this component, 0. So you can see here, the direction of the resultant is like this. Again, this is equal to the movement, the curl of the left hand finger. So this is also left hand elliptically polarized, right? So option B is also correct. Right? Option A is also correct. Now coming to option C. I can write first E directly. E is AX cos omega t plus AY 2 cos omega t plus t pi by 2. So at t equal to 0, let's see first what is the equation. E will become AX plus t pi by 2 is 0. So that is 0 dot Ay at t equal to pi by 2 omega. E will become pi by 2, that is 0 Ax. And this is pi by 2 here, and 3 pi by 2 will become 2 pi. It is 2 Ay. Now here if you see, so at 0 it is Ax, Ax is the resultant of 0 only, and this is 2Ay, it is here. The time increases, does not the direction, right? So now you can see the movement is not like this, the movement is like this. It is at t equal to 0, at t equal to pi by 2. That's where the time is increasing, the vector is rotating in this direction. So this is matching with the right hand, right? So it is not left hand polarized, this is right hand elliptically polarized. This is not the right answer, right? Now we need to check option D also. Okay. So I just make some space over here, and we'll see D. So here in this case, E is going to be Ax cos omega t plus Ay cos omega t plus 3 pi by 2. Okay, so let us write down the equation. At t equal to 0, t is going to be 2ax. Cos 3 pi by 4 is minus 1 by root 2. So that will become minus 1 by root 2 ay. Right? At t equal to, I'll write 3 pi by at pi by 4 omega. It's for the sake of simplicity. E will become ax by root 2. Pi by 4 omega plus 3 pi by 4 omega, that will become cos pi, which is minus ay. Okay, now let us plot this. So what I'll do is, I'll try to plot this over here. Just check. I'm plotting this for the option D. So the first point is 2ax and minus root 2ay. That point is somewhere here. You can write somewhere here. Okay. This is 2ax minus 0.707 ay. This is at t equal to 0. T equal to pi 4 omega. This becomes more negative, and ax by root 2. So that will come somewhere here. T equal to pi by 4 omega. Okay. So again, you see the movement like this, which will match with the left hand finger. So option D is also the right option. So option A, B, and D are the right option for this. So it's a good problem, but it's a time consuming problem. If you give it rightly, then yes, you will get 2 marks. The problem with this only means whether the problem is easy or tough, the marks are always like you. So you invest a lot of time in this, but again, the marks are only 2. But yes, it's a good question. And from learning point of view, the polarization learning point of view, it's a very good problem. Okay. So correct answer for this problem is A, B, and D. C is not the right answer. That's the end of question for electromagnetic theory polarization part. The following circuit representing lumped model equivalent of an infinitesimal section of a transmission line. So in this, you have to identify which one of them represents that one. So the correct option for this is option B, C, and D. Right? If you look at the option, see why option A is not the correct one, because here the capacitance and the admittance part, right? The conductance part, the capacitance part and conductance part, they are having a different potential here, right? But in the actual thing, they both should have the same potential. This and this potential must be same. This and this must be same. Here we are looking at this, right? That's why option A is not the right answer. There is not much in this. Of course, it's a 2 mark question, but it's a simple question. So that is the answer for this. Right. Question from electromagnetic theory. A transparent dielectric coating is applied to a glass to eliminate the reflection of red light. Okay. Lambda is given as 0.75 micrometer. The minimum thickness of the dielectric coating in micrometer that can be used is. So the dielectric coating is something acting like a impedance matching, right? So if impedance are matched, then reflection will not take place because the reflection coefficient will be zero. Okay. So and then so actually you see there are three mediums in this. If I draw this properly, there is a glass. Then there is a dielectric coating here. Of course, I have made it thick, but it is not so thick. And then there is an air. So here there is a glass, dielectric coating. And here air, right? So air has got epsilon r equal to 1, mu r equal to 1. Glass has got epsilon r equal to 4, mu r equal to 1. We need to find out this, right? So first we have to find out dielectric constant of this, and then we have to find out what is the minimum thickness that is needed. So it's a quarter wave impedance match. So this distance must be lambda by 4. But what is lambda? We need to find out because lambda will change. It will not remain 0.7. So if you apply the principle of quarter wave impedance transformer, so I can write here the impedance eta 2 is root of eta 1, eta 3, right? And that is nothing but epsilon r1, epsilon r3. So this is epsilon r1, epsilon r3, here epsilon r2. So it is epsilon r2. So that will become root of 1 into 4, that is equal to 2. So the dielectric constant of this dielectric material must be, right? First thing. Second thing is, since it has to match the impedance, so here the lambda naught. So this is the first part. We have to use epsilon r2 in getting the thickness. So the lambda is going to be lambda naught upon mu r epsilon r2 in this region, right? So that will become 0.75 by root 2. So I can write this as 0.75 into 0.707, 0.53. Okay, so that will be nearly 0.53. Now, as a quarter wave transformer, this length must be equal to lambda by 4. So D is 0.53 divided by 4. That is 0.132. Answer is 0.13 or 0.13 micrometer. That should be the length of thickness of the dielectric coating. Okay. So the concept that we use here is, first is it needs to have impedance matching, and impedance matching is carried out between the two medium by using a quarter wave transformer or this, which is of lambda by 4 length transmission line, or let's say not transmission line in this case, dielectric coating. Similar phenomena as what we see in transmission line applicable in the plane wave propagation. So there we make use of this relationship to get the impedance of this. And then finally for since it is quarter wave, so it is not only this lambda by 4, it is odd multiples of lambda by 4 it will be applicable. Okay. So lambda, for n equal to 0, we will get minimum thickness, but it is not only 0.13, there are multiple thicknesses in the multiples of lambda by 4 where we can get the impedance. So that is the thing. So answer for this is 0.13 micrometer. Okay. That's the end of question from electromagnetic theory. Question from electromagnetic waves, electromagnetic theory. It's a 1 mark question, and we have to determine the relationship between Vp and Vt with respect to C. Consider a narrowband signal propagating in a lossless dielectric medium. Epsilon r is given as 4, mu1 is given as 1. Okay, so dielectric medium, dielectric constant is 4. With phase velocity Vp and group velocity Vg. Here the following statement is true. C, the velocity of light in. Now, it is given that it's a narrowband signal. So, for a narrowband signal, Vp and Vg remain same. Okay, so there is not much change. So, that is the concept that we need to understand here. If you mix this concept with the concept from the waveguide, there you will find the relationships are different. And by looking at those relationships, you will find that option D, not option D, option C will be the right answer. But that is not the case here. It is not a propagation in a waveguide. It is a propagation in a dielectric medium. Okay, so that's a question here, and let me just see. Vp, the phase velocity Vp is omega by beta, frequency is constant, and it is C upon mu epsilon. So I should not write it. It's 1 upon root of mu epsilon. Okay, so that is 1 upon mu naught mu r. So 1 upon root of mu naught epsilon naught is c. So that becomes speed of light, which is nothing but mu r. And you can see clearly that Pp is going to be lesser than c. Right? So either option B or option D will be the right. Okay. Now coming to this Vd, for narrowband signal, Vp equal to Vd. It implies Vp lesser than C, Vd is also lesser than C. Option D is the right answer. Okay. That's the end of question from electromagnetic theory.